Good afternoon, everybody. Oleg Muravskiy, RIS NCC, and this talk is about our routing information system. It was supposed to be 2017 update, but I want to start with the question, who knows what this is? RIS. Okay, so I suppose not that many of people actually not just know it, but also use it. So I think I will more explain what it is and what could you do with it, and not just an update, because the system is, so RIS is a routing information service. It is worldwide network of BGP collectors. We deploy them at IXPs. We collect raw BGP data, we send it to our office, and we put it in archived format on our FTP and web pages. We started in 2000, so we have a lot of years of history there, and it could be used, and it is used by both operators and researchers all around the world. So this is the map. Currently we have 18 operating collectors in different places. We deploy 2 more, one in Romania and one in Singapore. We peer with more than 600 peers, and more than 150 of them send us their full tables. As you could see, there is a bit of a white or not that many dots between words Europe and Asia in this graph, and this is where we are. So if you are interested in hosting or sponsoring RRC box in this region, please talk to me or to RIS NCC. More about it at the end of the talk. So why we are doing it? The project was defined in official RIP document, RIP 200, in 1999. And in general, the summary from this document was, in other words, it can be regarded as the integrated Lookingglass for the entire internet that includes history information. It's not that this Lookingglass information was not available at the time, but basically back at the time, and what I see from other presentations today, in order to troubleshoot your routing problems, you have to do some trace route, figure out where it breaks, go to a specific Lookingglass and look in there what's happening, and then continue it until you find where the problem is. So it was already known as a problem back then, and the goal of the system was to collect information from many places, put them all together, and keep the historical information about it. So you could troubleshoot it live, and you could also look back what happened in the past. So yeah, the idea is that you instantaneously see this Lookingglass information from many places, and apart from this raw data and Lookingglass, we also keep all the statistics for the years and collect some metrics. There are similar services available, and we just saw presentation in the previous slot from another project very similar, where they collect data from Lookingglasses, mostly in Russia. So yeah, very similar. Why would you use us? We are neutral, we are not commercial, so all this data is available for free. We want to support our members, so you, and mostly you are the operators. We also support a larger community, researchers all around the world, and we have already some experience with doing measurement projects. So we used to have test traffic management measurement before. We have RIP Atlas now, and this project. So how could you get to the data? We have raw data for more than 15 years. It's almost 6 terabyte compressed binary now. You could go and download it yourself. It's MRT format described in RFC standard. We provide a command line utility to read it. There are also other implementations, at least in Java, in Python, other languages probably as well. Did that sound like a joke? Because yeah, you could do this, but this is not what we mean. We of course have a web interface for it and the API. So yeah, this amount of data is fed into RIPE-stat, and yeah, it's a big chunk of data that you see here. What is RIPE-stat is our web service. So basically, it knows everything you want to know about IP addresses, prefixes, AS numbers, or almost everything you want to know, maybe sometimes more than you want to know. How to use it? It's very simple. So you start with a search, and these are the things you could put in the search box. And here I just went and typed in random prefix. It appeared to be here in Belarus, and it even belongs to our hoster by. And then you see that the information on RIPE-stat is arranged into a series of widgets. They're grouped by different categories, and we're gonna focus on the routing category here. So what could you see there? This is the routing status widget. Simple, green or red, yes or no, is this prefix currently seen on the internet. So here you could see that it's visible by all of our full peers. You could also see when we first saw an announcement of this prefix back in 2005. Currently it's originated by IS 6697. There are no less specific prefixes, and yeah, there are some other settings that you could tweak and see more or less information. Routing history widget, this is where the majority of data we collect goes into this widget, because it allows you to see the whole history of announcements for this prefix. So on the bottom you see the timeline starting from 2005 until now, all the time span that we saw these announcements. You could see which ISN announced it and which prefix is there. And the interesting bit that yeah, you could select an area of this graph and zoom in time to see more detailed information. So yesterday we had an interesting presentation from SelectL about debugging the routing problems, and I also went to see in our system what happened back with their prefix at that time. So I zoomed in 2007, and I see, and you could see here on the right side, there are many more specific announcements that were seen by our peers, and this is not what they expected to see. And if you hover over one of them, you see this specific announcement that they mentioned was the problem. So you could see it now in our system as well, and this shows you where the problem or potential problems come in. You could also see here that this is not the only IS that announces more specific, so somehow what they think is route leak is still visible even right now. So if you scroll all the way to the right side today, you still see announcements of these more specific prefixes, which is interesting, and maybe they should look into it. Next example, the actual Lookingglass. So currently we have Lookingglasses on 14 of our route collectors. So you see them all in the list here. You could expand any of them and see the information right from routing daemon, well, just a normal Lookingglass you used to, but all of them collected in one place. So it shows you the current situation. Visibility widget is also simple. It basically shows how your prefix is visible by our peers all around the world. So in this case, everything is okay, everything is green and 100% visible. Widget, very interesting widget. So you see now what it shows is the changes in AS path between our peers, which are blue, and the target origin AS, which is red, in time. So you see how the IS path changes because of some announcement withdrawals. Yeah. And we also have some country statistics here. So this is just for the whole Belarus. the number of announced prefixes, IPv4, IPv6, and the number of ASNs doing announcements. You could see it for every country. And yeah, apart from that, how could you access the data? So we have this web interface. The web interface actually uses the API. And the API is completely public, and API has even more data. So every widget uses the API, but we have more APIs than the widgets there. So I encourage you all to go there and explore the API. Link is here. And yeah, try it out. If you want to script something, here you go. And yeah, one of the examples, the BGP state API. So if you remember, all started from these instantaneous Lookingglasses. So this is how you get this information from the API. And again, I used the example of SelectL. So if you put the prefix in or IP address in question and the timestamp in this API and do the call, this is what you get back. So there are 44 routes that you could see here. And yeah, this shows the problematic announcements. Another thing that we have is the live stream. So essentially the information that is available on web interfaces and the APIs is it's aggregated. So the aggregation is done in batches. It's not very much live. So the data we get arranged in 5-minute updates files. So you have at least 5 minutes of delay and then maybe some more delay for processing data. Yeah, what we also experiment with is you could now get the live data. So let's try to see if that works. Yes, I have to move window over there. So this is basically the widget. Let me open it and start it. Yes. Yeah. So you see basically these are all the live data that comes in and it could come to you. Obviously it is a lot of data, so you could experiment with filtering it by different criteria. You could see on the left side all the things you could filter on. So you could create a filter which is specific to what you are interested in, and then just see the data. This is JSON representation of BGP announcements. And you could see the delay here in this column, so it's pretty much live, and yeah, you will receive a lot of information. Let's go back. What else can you do? So this was like the data that we already pre-create for you. You could also grab all the raw data and do some analysis, and some people already did some analysis, so I only focus on those that are available on another our site, labs.tribe.net. For example, this one, there was a talk some time ago about what we're gonna do when there is no more IPv4 left, and maybe the only prefixes that are left will be smaller than /24. If we start announcing smaller networks, what's going to happen? And yeah, we just tried that. So we received allocations which are smaller than 24, and we announce them regularly, and we see how visible they are on the internet. So you could read more about it in this article. Another is, for example, how different prefixes in IPv4 are visible. Do all peers see them equally, or some are not? So yeah, you could see everything which is smaller than /24 is pretty much not. But even if between 29 and 24, there are some yellow parts in these graphs, so some things are not visible. So the question is why? Could be several answers. Similar picture for IPv6. You see there are even red parts in what we would consider to be the normal size of prefixes to be announced. Maybe this is just because some things are happening there, so things are announced, withdrawn, and not everybody sees them. But yeah, these are questions for operators. This is an interesting study, basically how fast any update propagates. So if you look at the time when we did the announcement of some prefix, when this specific announcement will be seen by all the peers, and it appears to take about 40 seconds before it's propagated everywhere. And if you look at withdrawal, it's even longer. For some reason, it takes 140 seconds when everybody does not see this specific announcement. Yeah, so we started small and the data grows over these years. So let's see at these dynamics. So these are all the collectors that we have now in different places. And this graph shows how many data we now publish per month from all these collectors. And these are just raw BGP updates. Per month, you could see that we are now producing over 50 gigabytes per month from all of them, but this is only half of the data we publish. These are BGP dumps, and this is even more. We are now over 60 gigabytes per month. So we were looking at these graphs recently and thinking, is it really that internet is growing that fast and nonlinear, or we are just adding more collectors and more peers and these things? So I went looking into, let's see, how many peers, or how many prefixes we are actually seeing, and this is only data for the last 2 years. These are not really the routing table sizes, it's just the number of different prefixes we see. And it's still growing. So 2 years ago, it was just above 600,000, and now we are over 700. And yeah, you could see it broken down by size of prefix. Something strange started to happen like in the past 3 months, where we see the bigger prefixes, bigger networks started to be announced more than the smaller ones as well, but the growth is actually seen in the slower part of the graph. And similar picture for IPv6. Yeah, the growth in absolute numbers is not that big, but yeah, it's more dynamic, I would say, but nothing spectacular or unexpected here. Yeah, so we do have more and more data every month. How do we deal with it? System was created very simple at the beginning, so this is the original design. It's even in RIP to 100 documents. You could see here things mentioned like a server, RIS server, and a database. So we started with just one server and one database, and over 4 years, apparently that was already not enough, so we split it into 2 servers and database replication, and it was not good enough back then, so that architecture was called RIS Classic, and we created RIS-NG because the data insertion actually was taking more time than, so to insert data for 1 day, it took more than a day sometimes, if something happened during that day. So we had to do something, and yeah, during the years, there were different solutions put in place, and we were basically moving this data collection between the endpoint, the RRC itself, and the central node, and then back and forth. And back in time, it appeared to be like maybe a good idea. Let's put MySQL somewhere there, collect it locally there, and just send it here. But no, this does not work. We still had many problems. The insertion became even slower. We only could keep 3 months of data, and then all the indexes went broken and not working. So yeah, the solution was, let's go for big data. This is what we are doing now. So we run on Apache Hadoop, and this allows us to keep all the data online for all these 15 plus years. We have several clusters. The biggest one is 150 nodes now. Yeah, these are the components that we use, pretty much standard for any Hadoop environment. Distributed file system, HBase is a database. It keeps all the aggregated data. MapReduce is our engine to compute all the aggregations. Azkaban, it's like cron tab for Hadoop on steroids, which provides more useful services. Kafka is very important, so we are now switching into this messaging mode. So we are not just taking data in batches and in files. We receive live streams from our BGP daemons, and this is basically why we could have this web interface with the live stream that I just showed you. But even that was not enough, because just scaling the backend didn't solve all our problems. So what we used to do in the past, we were running Quagga as single BGP collector per RRC. It is single-threaded, so that creates some problems. Even if we put Beefy machine, it still runs just one thread, so we cannot use all the cores. Another, I would say, unexpected problem that when you're doing the dump file, this is basically the data that we are collecting, all the other processes stop. So we need two types of data, like 8-hour dumps and all the row updates. You could get only one of them at a time. So if you collect one of them, the other data somehow disappears. So yes, this is time for another redesign, and this is what we are doing now. So 4 of our collectors are already running in this new model that I'm going to present now. Basically, we switched from Quagga into ExaBGP. It is a lightweight daemon because we don't really need a full BGP daemon. We do not do actual routing with our collectors. So we do not need to calculate all the routing tables. We just need to get the feed of the data. So with this lightweight daemon, we could easily run 10 of them on each of our collectors. And finally, we could actually use all the cores, all the 4 cores that we could have now, that we currently have in our architecture. We use message queues. This is what I already said. We started with RabbitMQ. Unfortunately, this does not scale. It cannot keep up with the rate of BGP updates. So we replacing it with Kafka now. Kafka is much better in shuffling all these data around, especially when something happens. Even when just one of our full peers restarts, it immediately sends like 600,000 of messages. So we have to effectively ship them back to our Hadoop infrastructure. So this is where Kafka and stream processing comes in. We are switching from batch processing to the stream processing. So if you look at our widgets now, it sometimes shows the data granularity is 8-hour and some data is 8-hour like back in time. So this is because we still use this batching processing, and not all the data is really up to date, but with stream processing, like the new Lookingglass, will be also instantaneous. Yeah, so this is basically the grand picture. Yeah, it shows 2 of these remote collectors. They have many peers attached to them, running through ExaBGP, storing some messages locally, then sending them back to our cluster. And then we have these consumer application. They are consumers in terms of messaging systems. So they consume messages from this system. And let's look at the next picture. Yeah, doing these further processing. So we create all these data that I just showed you in all the screenshots, plus they generate all the dumps and everything else. And this is what I am actually doing. So this is where I come in place. Yeah, and the last couple of slides, how could you help in here? Yes, basically just come and peer with us. If you are in one of these IXPs that on the right side, then we are still open for peerings on those IXPs. Our AS is 12654. You could simply go to this URL, fill in the form, and we will contact you. And what we need from you is send us all your peers, all your routing tables if you could, or if not, then just send us what you have. And another thing, as I said, there is a bit of an empty space in here. So if you are interested in hosting or sponsoring RFC box at your IXP, then also please either talk to me after the session or send a mail to ris@tribe.net and we will sort it out.